Today we are going to see how an interact system works in Unity 3D using C#. We will build a simple but complete setup where the player can look at objects, highlight them, and interact with them in real time. A raycast in Unity is a way to simulate a straight line projected into the game world to check if it intersects with something. It starts from an origin point, usually the camera or a specific object, and moves forward in a defined direction. When the ray is cast, Unity checks along that path to see if it collides with any object that has a collider. If a collision happens, the system returns detailed information about the hit, such as the exact point of impact, the distance from the origin, the surface normal, and the object that was hit. This makes raycasting extremely useful for interactions like shooting, selecting objects, or detecting obstacles. If the ray does not intersect with anything, no data is returned, which simply means nothing was detected along that path. It's important to understand that the ray itself is not visible in the game unless you explicitly draw it for debugging. It's purely a detection tool. Start by creating a script that will handle player interactions. This script will define how the player communicates with objects in the world. To keep things flexible, define an interface called iInteractable. Inside it, declare three methods: interact, onFocus, and onLoseFocus. These are just method signatures, so there is no code inside them. Next, set up the variables needed to manage player interaction. Start with a reference to the input system, using starter assets inputs, so you can detect when the player presses the interact key. Then store a reference to the main camera, which will be used to cast a ray forward into the scene. You also define a ray distance, which controls how far the player can interact, and a layer mask to make sure the ray only detects specific objects, like interactables. To handle feedback, keep track of the current outline component, which can visually highlight objects, and the reference to the current interactable interface, so you know what the player is targeting. Finally, add a small timer and delay to manage losing focus smoothly, avoiding flickering when switching between objects. In the start method, initialize everything by assigning the main camera and getting the input component from the player. This ensures all references are ready before interactions begin. These two methods are responsible for cleaning up the current interaction state when the player is no longer targeting an object. Clear outline handles the visual feedback. If there is an active outline component, it disables it so the object is no longer highlighted, and then removes the reference by setting it to null. This ensures that the previous object doesn't stay visually selected when the player looks away. Clear interactable focuses on the interaction logic. If there is a current interactable object, it calls onLoseFocus, which allows that object to react, for example by hiding UI prompts or resetting its state. After that, the reference is cleared, so the system no longer considers it as the current target. The outline effect used here comes from an external asset, not something built into Unity. It's an outline component from the asset store that allows you to easily highlight objects when the player looks at them. I'll include the link to the asset in the description so you can download and use the same setup. In this method, I handle how the outline changes when I look at different objects. First, I check if the new outline is valid and also different from the current one. This helps me avoid doing unnecessary work if I'm still looking at the same object. If it's a new target, I call clear outline to remove the highlight from the previous object. Then I assign the new outline to my current reference and enable it, so the object I'm looking at gets highlighted. Here I'm inside the method processMiss, and this is what I use when the raycast is not hitting anything. Every frame, I increase a timer using time.deltaTime, so I'm basically measuring how long I've been not looking at any interactable object. Once this timer reaches a small delay, I call clear interactable and clear outline. This removes both the interaction reference and the visual highlight. I do this with a slight delay instead of instantly, so I avoid flickering when moving the camera quickly between objects. Right here we have a function called processHit, and it receives a raycast hit, which is basically the information returned when a raycast hits something in the scene. First thing we do, we reset a timer called loseFocusTimer, setting it to 0. This is useful because it tells us the player is still focusing on something, so we don't want to lose the interaction state. Next, we try to get an outline component. We do that using hit.collider. GetComponent in parent is less than outline, is greater than. This means we are looking for an outline script not only on the object we hit, but also on its parent objects. After that, we get an iInteractable interface using hit.collider. GetComponent in parent is less than iInteractable is greater than. This allows us to detect if the object we are looking at can be interacted with, like opening a door or picking something up. Finally, we call handleOutline, passing the outline variable. This function is called handleInteractable, and it receives an iInteractable object called newInteractable. First, we check if newInteractable is not null, and also if it is different from the current interactable we already have stored. This is important because we only want to update the focus when we actually look at a new object. If there is already a current interactable, we call currentInteractable. On lose focus. This means the previous object is no longer being looked at, so we remove its focus state. Then we update our reference by setting currentInteractable equal to newInteractable. After that, we immediately call currentInteractable on focus. This triggers the new object to enter a focused state. Now we also add handleInteractable, and in the parameters we pass interactable inside the previous method. So every time we detect something, we immediately update the focused object. We start by creating an array called array using cam.viewPortPointToArray, and in the parameters we pass a vector tree with 0.5, 0.5, 0. This shoots an array from the center of the screen. Then we declare a RaycastHit called hit to store what the array collides with. We use physics.raycast, and in the parameters we pass ray, outHit, ray distance, and item mask. This checks if something is hit within range and only on the correct layers. If the raycast hits something, we call processHitHit, and inside that flow we also update the interactable using handleInteractable. If nothing is hit, we call processMiss and reset the interaction state. Here we have the tryInteract function. First we check if current iInteractable is not null. If that is true, we call currentInteractable.interact, which triggers the interaction logic of the object. Then we try to cast the interactable into a mono behavior, so we can access the game object it is attached to. If the cast is successful, we destroy mono.gameObject, meaning the object is removed from the scene. Then we handle input in handleInteractionInput. We check if input.interact is true, and if it is, we call tryInteract to trigger the action. After that, we reset input.interact to false, so the input only triggers once per press. In the update method, we call handleRaycastDetection and handleInteractionInput every frame. Now we are preparing the scene. First, we place all the prefabs of the objects that will be interactable in the level. On each of these objects, we add the outline component and set it to false by default, so it is not visible at the start of the game. Then we make sure all interactable objects are assigned to the item layer. If the item layer does not exist, we create it inside the project settings. This setup is important because the Raycast system only detects objects on that specific layer. Now we create a new script called item in C# and we assign it to every interactable object in the scene. This script implements the iInteractable interface, so it forces the object to have interaction behavior. Inside the interact function, we print a debug message saying interaction with plus the object name. Inside on focus, we print focus on plus the object name, so we know when the player is looking at it. Inside on lose focus, we print focus off plus the object name, which happens when the player looks away. Now I make sure to add this item script to every interactable object in my scene, so each one can properly react to focus and interaction. I also remind myself that I can easily adjust the raycast distance directly from my player interaction script, which lets me control how far the player can interact with objects in real time without changing the core logic. At this point I can test everything in the scene, and I should see objects being highlighted on focus, showing debug messages when I look at them, and being destroyed or interacted with when I press the interact input. and this is the final result of the system working together. Thanks for watching. I really hope this tutorial helped you understand how interaction systems work in Unity 3D.